let's move to the second big idea in this lesson, area. If perimeter is about the distance around a shape, then area is about the amount of space inside the shape. That is the big shift. Perimeter is boundary, area is interior. Let's start with a shape that is not simple. We have this concave hexagon with these side links labeled. And this shape is a good example because it's not just a rectangle. And that reminds us that area is not only for nice shapes. To find the area, we can cut the shape into easier pieces. That is one of the most important ideas in area. If a shape is complicated, we can often decompose it into shapes we already know how to manage. For this one, I could add in a line right here to create a rectangle at the bottom, and then another line here. So now I have two rectangles and a triangle. This rectangle at the bottom would be 5 inches by 13 inches. So its total area would be 65 square inches. 5 times 13. Up here, this little rectangle, we see one side is 3. The other side, we have to do a little bit of work. We know 5 inches is from the bottom to this red line. And since the whole thing is 9 inches, this would need to be 4. 3 inches times 4 inches is 12 square inches. For our triangle, we know this side is 4. And the total length across the top, we have a 6 labeled and a 3 labeled. That gets us to 9, but we know the whole thing should be 13. So that tells us this is 4. Area of a triangle is 1/2 4 times 4. So that would be 8 square inches. So my total area, 8 plus 12 plus 65 would be 85 square inches. We find the area of each piece and combine the results. And it's okay if you didn't follow all of that. As we progress, we'll go into how to find the area of these different shapes and kind of bring it back together. It's also important to know this is not the only way to do this problem. This same shape could also be broken apart in a different way, perhaps into different rectangles and a triangle. I could have drawn a line here, here, and here. So now I have 3 rectangles and a triangle. That is an important idea for students. Mathematics is not always about finding the one approved pathway. Sometimes there are multiple correct approaches. As long as the pieces cover the same region without overlap or gaps, the total area will be the same. Now, let's ask another question. What about general shapes that may have curved edges, like this one here? Those are harder to break exactly into simple pieces. In that case, one useful strategy is to place a grid over the shape like I did here and estimate how many full or partial squares fit inside of it. We can count full squares and almost full squares and partial squares combined together. And this gives us an estimate of the area. Now, here's an important question. What if one student makes a grid using smaller boxes and another student uses larger boxes like I have here? Does that mean the area is different? No. The actual amount of space inside the shape does not change. What we changed is the unit used to measure it. It's just like measuring length in inches versus feet. The object does not change, only the unit changes. That idea is very important and leads us naturally to a more precise definition of area, which we'll do in the next video. Before moving on, let's summarize the big idea here. Area is about the space inside of a figure. We We can find area by thinking of covering or partitioning. Irregular shapes can be broken into easier pieces to work with. Curved shapes can be estimated using a grid. And different methods can still describe the same area. And that is a really powerful idea. You do not need every figure to be simple before you can reason about it mathematically. That flexibility is one of the most important habits students can develop. Great work so far.